For an enterprise with multiple campus branches or mobile branches, each branch requires communication technology devices such as routers, firewalls, load balancers, and WAN optimization controllers, and needs to deploy different information technology applications. In addition, deployment mode. The enterprise needs to deploy many CT devices and multiple servers for the applications. As a result, maintenance costs are high and services are inflexible. Virtualization is technology that can virtualize an AR device into multiple independent logical devices. The virtualization feature allows you to create multiple virtual machines on one physical AR router. Each VM functions as an independent device and has its own operating system, virtual network adapter, and application software. Compared with the traditional deployment mode of IT resources, virtualization has the following advantages: cost effectiveness, mutually isolated, secure, and efficient execution environments for applications, convenient management. Let's move to the application scenario of AR router virtualization. A small enterprise wants to deploy multiple Office's applications. In traditional deployment mode, the enterprise needs to deploy many CT devices and multiple servers for the applications. As a result, the deployment and maintenance costs are high and services are inflexible. Enterprises expect that common Office applications can be deployed on individual VMs of a router to reduce cost on application servers and simplifies device management. The VMs provide the same application services as the traditional application servers. Figure 1 shows the networking. An AR is virtualized into multiple independent logical devices after virtualization. First, let's figure out the changes in AR architecture. According to the new architecture, compared with the traditional AR router, the virtualized AR router adds and the Virtual Environment Management Platform. The VEMP operates on the host OS to manage VMs. Users can perform operations on individual VMs. That is to say, users can install the operating system and application software on each VM based on site requirements. The routing system, host OS, and VMs constitute a virtual system. As the lower layer operating system, host OS provides basic system services for the routing system and VMs. To manage VMs and connect VMs to the external network, ensure that the virtual systems, routing system, VMs, and host OS can communicate with each other. Let's learn basic concepts of VM communication mechanism. vSwitch. A virtual switch is created using virtualization technology and provides functions of a traditional switch. A vSwitch transmits traffic between VMs and connects VMs to the external network. A device supports a maximum of 4 vSwitches and has a default vSwitch, VR0. Virtual interface. A virtual interface is a logical interface that is created inside the system and connects virtual systems. The device supports the following types of virtual interfaces. Routing system virtual interface. It is created by the system by default and connects to a VM virtual interface or host OS virtual interface. The interface name is in the format of GE0-0-X, what is similar to the name of a common physical GE interface. VM virtual interface. It is created by the system by default and associates with a virtual network adapter. Dynamic host OS virtual interface. It is created by a user and connects to a VM virtual interface or routing system virtual interface. Default host OS virtual interface. It is created by the system by default. Each device has N+2 default host OS virtual interfaces. N is the number of vSwitches. By default, each vSwitch system creates a virtual interface that uses the same name as the vSwitch. The other two virtual interfaces are Veth1 and Veth2. Veth1, it is used to manage the host OS. Veth2, it connects to a routing system virtual interface and is added to the vSwitch by default. Virtual interface using the same name as a vSwitch. It is the management interface used to manage the vSwitch and is added to the vSwitch by default. Virtual links connect virtual interfaces of the virtual systems. The device supports the following types of virtual links. Default virtual link between the router and host OS. The system creates 2 such virtual links by default. Virtual link between GEO/O/O and Veth1 is used to manage the host OS. Virtual link between GEO/O/1 and Veth2. It connects the routing system to the host OS and enables the routing system to communicate with VMs through the vSwitch. Dynamic virtual link between the host OS and VM. It connects the host OS to a VM and enables the VM to communicate with the routing system through the vSwitch. Dynamic virtual link between the router and VM. It connects the routing system to a VM. Dynamic virtual switch between 2 VMs. It connects 2 VMs. Dynamic virtual link between the router and host OS. It connects the routing system to a host OS. Virtual systems, routing system, VMs, and host OS on a device must communicate with each other before communicating with the external network through the routing system. The virtual systems communicate using the following methods. Communication through a vSwitch. As shown in the following figure, a user sends packets to the physical router to access a VM. After receiving the packets, the routing system sends the packets to the VM through Virtual Link 5, vSwitch, and Virtual Link 2. After the application software on the VM processes the packets, the VM sends response packets to the routing system along the original transmission path. The VM can communicate with another VM through the vSwitch. The vSwitch can also forward received packets to other VMs connected to it. Direct communication through virtual links. As shown in the following figure, a user sends packets to the physical router to access a VM. After receiving the packets, the routing system sends the packets to the VM through Virtual Link 3. After the application software on the VM processes the packets, the VM sends response packets to the routing system along the original transmission path. The VM can also forward received packets to a connected VM. Virtualization can be configured on the AR3670, AR169-P-M9, AR169W-P-M9, and AR169RW-P using command lines or through the Agile controller. Configuration using command lines. The configuration is complex and is applicable to scenarios where there are a small number of closely located devices. Configuration through the Agile controller. The configuration is simple through the GUI and is applicable to scenarios where there are a large number of scattered devices.